Hi and welcome back to Alistair's Merchant Navy How-To series. In this short video I'll be explaining the terrestrial sphere before we move on to the principles and calculations involved with sailings. Before starting, I just want to say this is a very basic introduction to the terrestrial sphere, intended to highlight the minimum knowledge you require to carry out the various types of sailing calculations. It became apparent long ago that we needed a way to identify a position on the Earth's surface, and our standard coordinate system of latitude and longitude was born. This reference system is based on various mathematical principles, and there's some basic terminology that we need to understand before going on to using mathematics to calculate distances, courses and positions. Our Earth is not a perfect spheroid. It's an oblate spheroid, which means it's been a little squished at the top and bottom. It spins on an axis with its upper and lower extremities named the poles, with the upper being the North Pole and the lower the South Pole. Running from the North to the South Pole are a series of imaginary lines called meridians. As presumably the British were first, there is a special meridian called the Prime Meridian, which passes through Greenwich in London and is assigned as 0 degrees of longitude. We also have an imaginary line which divides the Earth into two halves, from east to west, called the equator. Running parallel to the equator is a series of other imaginary lines which are called parallels of latitude. In order to understand latitude, it's necessary to locate the centre of the Earth. If we draw an imaginary line down through the poles, and then east to west from opposite sides of the equator, we identify our point in the centre of the Earth. We know that the equator is 0 degrees of latitude, and we know that the North Pole is 90 degrees of latitude. If we look at our centre point, we can see that the angle between the two lines is 90 degrees. It follows therefore that each parallel of latitude can also be described in this way, and it can. If we take our imaginary 40-degree parallel of latitude and connect it to our imaginary point in the centre of the Earth, we see that the angle is 40 degrees. This can be explained by saying that each degree of latitude is equal to the arc of a meridian, or the angle of the Earth between the plane of the equator and a line from the centre of the Earth through the appropriate parallel of latitude. Now let's look at the difference in latitude, or DLAT as it is commonly called. Mathematically, the DLAT is described as the arc of the meridian between two parallels of latitude which passes through the 2 points. To put that in simple terms, it's the numerical difference between the two latitudes. If we use the example of 40 degrees north and 20 degrees north, we should have a DLAT of 20 degrees. Be aware that if you cross the equator, you have to take this into account. Remember, if our two latitudes have the same name, we subtract the two figures, and if our two latitudes have different names, we add the two figures together. So we've covered latitude, let's cover longitude. Longitude is measured between 0 degrees and 180 degrees, and is named east or west depending on its location relative to the prime meridian. The difference in longitude, or D-long as it's commonly called, is similar to D-lat, except that D-long is described as the arc of the parallel passing between two meridians of longitude which passes through the 2 points. To put that in simple terms, it's the numerical difference between the two longitudes. And remember, much like with latitude, if our two longitudes have the same name, that is both our west or both our east, we subtract the two figures. And if our two longitudes have different names, we add the two figures together. This video has been a quick introduction to the terrestrial sphere. I have made this as a separate video as it's necessary to have a brief understanding of these points when it comes to doing our calculations for parallel, plane, Mercator and great circle sailings, which I will be covering in later videos. Thanks for watching. To make sure you get notified when I post the next video in my Merchant Navy How-To series, please subscribe, and if you found this video useful, don't forget to hit the like button. Until next time, safe sailing.